Hey folks, Paul Abernathy here. In this video, we're going to talk portable generators. We're going to talk about the difference between a floating generator and a bonded generator, and when you might use one for supplying power to a dwelling, okay? And then when you'd use one for like just portable use, job sites, camping, and things like that. And when you would need one that's considered a floating neutral, maybe, or one that's a bonded neutral. Well, what's the difference? So we're going to be looking at that today in this episode. Again, all of this is out of our grounding and bonding program, and you can go find more information about that here at the Fast Track System. But we're going to talk about, again, today, portable generators, and we're going to be working out of the 2023 edition of the National Electrical Code. So all of our references are going to be out of the 2023 moving forward in this episode. So keep that in mind if you're happen to be watching the video and you're wondering maybe something doesn't align with your 2020 or 2017 edition as far as the code references. We're working out of the 2023. Okay. All right, so we're going to be looking at 250.34 portable. Now we're going to be looking at the vehicle mounted or trailer mounted generators in this episode. We're just going to be focusing on portable generators. And there's a lot of stuff that's quite confusing about generators that we've learned over the last couple cycles. Is that, you know, when would you want one that is the frame of the generator bonded to the neutral point? And when would you want to have, or when could you have a floating neutral type generators? So we're going to be looking at those and trying to break it down to maybe simplify it a little bit for those that are looking to buy a generator, or maybe you have a generator and you're using for a current application and you really don't know if it's safe to be using it, what you're using it for, and maybe you just never run into an issue where you tested the safety of the design because it's never come up, those type of things. So we'll kind of look at that. We'll read along because, again, it's so important for us in this program to follow the written content and then elaborate on that written content. That keeps us on track with the material. So we'll be looking in at 250.34a portable generators. Now, let's look at the requirement. It says the frame of a portable generator is not required to be connected to a grounding electrode as defined in 250.52 for a system supplied by a generator under both, okay, both, important to highlight that, both of the following conditions. So what this is basically saying is, okay, I have a portable generator and I do not have to drive ground rods or establish a grounding electrode system for this portable generator if the following conditions apply. And there's two of them, and you have to comply with both of these conditions, or the generator has to comply with both of these conditions. Okay, so here they are. The first one is the generator supplies only equipment mounted on the generator, cord and plug connected equipment through receptacles mounted on the generator, or both. All right, so what's important to this one, to me, is the or both. So if I have a portable generator that's got receptacles built into the generator, which is typical of a portable generator, then I do not have to have a grounding electrode system for this generator. Okay, now that's the first part. The receptacles are mounted on it. Okay, next, if I had a generator that was specific to a piece of equipment, and that equipment is actually mounted on the generator, then again, I would not have to establish a grounding electrode for that generator. Okay, so assuming you meet that first condition, then no electrodes are required for your portable generator. Next condition right here, it says the normally non-carrying metal parts of the equipment and the equipment grounding terminals of the receptacle terminals are connected to the generator's frame. Okay, all of that's extremely important. So this says that the frame, metal frame of the generator has to be connected together with, if there are receptacles on this generator, then it would have to make a connection from the frame over to the terminals, right? For the equipment grounding terminals on the receptacles, all connected together. And ultimately, it's going to connect back to the grounded point or the neutral point on the actual generator. Okay, so this is what we refer to as a bonded generator. Okay, it makes all the connections, but don't worry, we'll look at a graphic that'll kind of make it all make sense for as far as generators go. But before that, we got to have a little bit of a discussion, and here's our discussion. And oh, by the way, This is indicative of how our course goes. We're not just going to give you a code reference. We're going to also gotta kind of give you the code, but then we're going to kind of go into a description. So anything that can make the NEC easier to understand is important. And that's what these courses all do in our Fast Tracks program. It tries to make things as easy to understand as possible. You're still going to obviously have questions, but the effort is to try to make things as easy to understand as possible and support it with illustrations where necessary to kind of ease that understanding. So let's look at it here. So as illustrated in figure 2-70, which is down here, we'll see in a minute, it says the system neutral and the equipment grounding conductor of a portable generator are required to be bonded to the frame of the generator. It's kind of what it said up here in item number 2. Okay, now, without the connection between the neutral and the equipment grounding conductor, a path does not exist for current from a line to ground fault to return to the source. Remember, it's trying to get back to where it originates, okay? Never trying to get to earth. So if it originates at the generator, the windings, it goes out, serves the load, everything comes back. It's all trying to get back to the source, okay? All right, so if you don't have that connection from the frame over to the neutral point and something gets energized in some metal parts of the piece of equipment that's plugged in to the generator, or something happens on the frame, if it can't get back to the source, then it's not going to be able to clear an overcurrent protection device. Okay? So that could be very much problematic, right? So keep in mind that all equipment must comply with 250.4a by providing an effective ground fault current path. Now, we're all pretty familiar with that in the code. We're required when we take out branch circuits and we make all of our connections and we do everything, we use proper terminations in accordance with 250.8, then what happens is we're establishing an effective ground fault current path. Well, there's no different here on this generator. So we have our receptacles with our equipment ground terminals. Okay, it's connected to the frame. The frame is connected to the neutral point on this generator so that we can complete that cycle and allow the overcurrent device to function and to allow the GFCIs to function that are typically built in to these portable generator setups. Okay. All right, so let's look at this real quick. So here's a generator, very standard generator. This is a 5,000 watt generator. You notice here's the metal frame. Okay. You notice it's on non-metallic wheels, plastic wheels, so it is not contacted with the earth. Okay. Now, this frame is not required to be connected to an electrode under the specific conditions that we just read. Okay, now obviously here are the receptacles that are built into the generator. That meets one of the components. The other aspect of this to not have to have the electrodes is that it has to have the connection from the neutral point and from the equipment grounding terminal connections here on these receptacles over to the frame. Okay, all of that has to take place. All right, what does that look like in an illustration? All right, so here's that generator right here. So this is the generator above, drawn out in an illustration. So here's phase A, here's phase B for the 240 volts. Here's the neutral, so phase A to the neutral 120, phase B to neutral 120. All right, so here's all of our setup. Here is your connection right here that creates this bonded generator over to the frame. So the equipment grounds are connected to the neutral point. Everything in this frame is connected to the neutral point, all meeting the requirements that we just saw. No electrodes are required for this portable generator. Make sense so far? Okay. Now, remember, we're looking at the 2023 edition of the National Electrical Code. And why is that important? Because there was basically a change in terminologies and in technical jargon and how we explain something. And let me read it to you and you'll get a better understanding, especially if you're in a 2020 or 2017 edition and you see us doing this 2023, you're thinking, okay, isn't that metal frame acting as an electrode and that's why we don't have to have an electrode? No, it's not, because that frame is not connected to earth, so it is not an electrode, right? So let me read it here. It says the NEC no longer refers to the frame of a generator as serving as the grounding electrode for the system produced by the generator. It can't be. because the whole premise here was it doesn't have electrodes. It's not connected to Earth. It says, this section previously stated that the frame of a portable generator was not required to be grounded and was permitted to serve as the grounding electrode for the system supplied by the generator. That is not technically correct, because it's just the metal frame that has to be bonded to the neutral point. Okay, so again, this is a statement that might have been used in the past, but it's been clarified. So it says the present language is a technical correction to the code because the frame of a generator is not grounded unless an earth connection is made through one or more electrodes, grounding electrodes. And we just saw that they're not required on specific portable generators that meet the conditions. Now, it also goes on to say grounding type receptacles and ground fault circuit interrupter receptacles are typically installed on portable generators for supply of equipment through flexible cords. Okay, so we kind of saw that here in this illustration. Here are the receptacles. Everybody's seen it. You go buy your portable generator, whether you use it for a job site, construction site, campsite, however you want to do it, that's your portable generator. Okay. Let's dig a little deeper here. And I've got an important area highlighted here for you, but let's see here. Portable generators. Now, there are two different types of portable generators that you're going to run into. You're going to get some that are the bonded neutral, like what we just saw, okay? And then you're going to get a floating neutral. Now, if you think of the bonded neutral, the one we just talked about, then that's going to meet the rules, and that's going to allow the overcurrent devices on the generator to trip. That's going to allow the GFCIs to function properly. Whereas on a floating neutral, that just can't happen. Okay. Now, that doesn't mean that you're not going to overload and trip an overcurrent device, but it's just, I'm going to show you how it really can happen when it comes to the floating neutral. Now, that doesn't mean that it's not going to work and you're not going to plug an extension cord into it and you're not going to get power. Obviously, you are. But when you need those devices to function safely and clear a fault, then that's when the problem occurs. And you might say to yourself, well, I've never tripped a breaker on my floating neutral generator. There's probably a reason why that hasn't happened, okay? Now, portable generators with a floating or bonded neutral. Portable generators are available that do not have the neutral connected to the frame. They're available out there. These generators are often referred to as a floating neutral generator. Since there is no path for ground fault current to return to the windings, get back to the source because it doesn't have that jumper, okay, then line to ground faults such as from a faulty tool or appliance will not be cleared. They will not function the overcurrent protected device properly, okay? So it creates an unsafe condition. So if you're using tools, they get, if you're still using corded tools on job sites, then again, it can create an unsafe condition if you're using a floating neutral type generator, okay? All right. Also, now we get to the green part. Let me get rid of this to get rid of that here. Also, a GFCI device that is intended to protect people from electric shock hazard cannot function. Thus, these generators should not be used as standalone operation. So, floating generators that do not have a bonded neutral to the frame, you do not want to use on a job site, construction site, maybe for your camper or something like that. You don't want to use them in those applications, okay? If you're relying on that overcurrent device, on that generator, if you're relying on that GFCI device to function properly, you do not want to use a floating neutral generator. You want a bonded neutral generator. Let's meet a little more here. It says, you should be aware that generators of this wiring arrangement, that is the one that's the floating neutral, by the way, do not comply with the requirements of 250.24c that the neutral conductor be bonded to the frame, okay? So again, first of all, trying to meet NEC rules, and this is going to become even more important if you happen to try to use one of these generators to supply like a dwelling or something like that, then it becomes pretty critical that it can't comply with 250.24c if it's a floating neutral because you don't have that neutral to the frame connection. Okay, that's a problem, right? All right, next, is there a safety standard for these generators? Yes. So that safety standard comes from the Portable Generator Manufacturers Association. That's this right here. And they are ANSI PGMA G300, and the latest edition, I guess, was the 2018. It hasn't been updated since then, since this is 2023 information. And they're going to give you the standard. Now, in that standard, it's going to give you various details of the construction of a generator. And it's also going to tell you the instructions on bonding the neutral to the frame if the generator has 15 or 20 amp, 125 volt receptacles. Then it's going to say, hey, if you've got these receptacles, guess what? I'm going to need you to bond the neutral to the frame of this generator. Okay? So that's where you're going to get all those instructions. Now, when it comes to generators, the only other thing I can tell you is you have to be careful because there's a lot of makes of generators, and not all generator manufacturers understand the difference and the importance of what they're selling their generator for. Most of the portable generators that you would see out there, you'd have to think they're being used in a portable application as a standalone, as a separately derived type system, right? And so if that's the case, we want to make sure we have that system bonding jumping in there, or that connection from the neutral point over to the frame. Okay? We want to make sure that takes place in those type of systems. But you got to be careful what you buy, okay? So you know what you're getting. And I would also say for homeowners, the people that want to buy just a portable generator to try to do backup power for their house, be very careful, because a generator with a bonded neutral is a separately derived system, right? And so when you have that connection and you get, let's say, a transfer switch and you don't pay attention, and you get one that is has that bonding in it like that, then you don't get a transfer switch that switches the neutral, then you're going to get parallel paths of neutral current traveling, and that is an unsafe condition, okay? Because basically you have to understand that what you're dealing with is parallel paths of neutral current. So it can be really unsafe. But we'll look at all that in an example and kind of show you what can happen. But don't worry, we'll dig into that in a minute. All right. Next, portable generators with the floating neutral should only be used if connected to a premise wiring system through transfer equipment. Okay, so if you have a generator and is a floating neutral type generator, then you should make that application through a transfer switch. Okay, now, because if it is floating neutral, by the way, then you've got the separation, right, between, you don't have any jumper between the neutral and the frame. Okay, that type of scenario. So it's technically not a separately derived system at that point. Okay. All right, so let's look at what we're dealing with here. Okay, so line to ground fault currents can travel over the equipment grounding conductor to the service equipment and then back to the generator through the neutral conductor. Obviously, for this type of generator, the neutral should not be switched in the transfer switch equipment and should be located very close to the service to keep the impedance of the completed fault circuit to a low value. Okay, so all proximity taken into consideration where you put this equipment. One of the biggest things that I always run into with people is when they do a generator for their house and they determine whether or not, depending on what happens in the transfer equipment, right? If the transfer equipment switches the neutral on it, okay, just breaks the neutral, then what you have is a separately derived system, okay? Now, if it doesn't switch the neutral, then it's not a separately derived system, okay? So it's important when you're selecting the equipment to know what you're doing. But don't worry, we're going to dig even deeper. We're going to look at this, okay? Now, only portable generators, and again, we said this, so redundancy here, only portable generators that have a neutral bond to the frame should be used in a standalone function such as temporary power to construction sites, picnics, concerts, and so forth, okay? So if you're buying generators for any of these applications, they're temporary power, construction sites, pull it up, run the job site, you want to make sure that you have one that has the neutral bonded to the frame. So you want a bonded generator, okay? If you take anything away from this, that's what you want. Why? Well, because that's going to allow the overcurrent devices to function properly, and that's going to allow the GFCI devices to function properly on the generator itself. Now, also as defined, the definition of ground fault circuit interrupter in Article 100 is for portable generators, the frame is permitted to function as earth or ground for the generator. Okay? GFCI devices will function as intended only on portable generators that have the neutral bonded to the frame. Right? Can't make that even as clear as we can make it. Okay? GFCI protection cannot function on generators that have a floating neutral. Again, not sure how clear we can make that to folks. Okay? Why? Because there isn't a return path for the ground fault or stray current to return to the windings, back to the source of the generator. It's basically just going to stop on the frame. And that means that it could stay energized. It's not going to clear anything. Now, somebody comes up and makes contact with it, provides that path. Again, that's where people get hurt. Okay, so very important. So we want to look at an illustration that kind of lays this out. So let's look at this illustration. Well, kind of not an illustration, more or less a chart on what you can remember here. What the takeaways. So if you happen to have a generator that's a floating neutral, and that's what's marked on your generator, then it will not clear a line to ground fault because there isn't any path to get it back to the source, right? It also will not function for a ground fault that would clear a GFCI device. Since there isn't a path for current to return to the generator windings, on a floating neutral generator, it will not function properly. Now, neutral bonded generators, okay, the one that has that jumper, first one we talked about. The overcurrent device will operate as normal, allows that ground fault, allows that current to skyrocket at the point of the fault, allows that to get back to the source and complete that path. Now that overcurrent device will function quickly as it's supposed to. And then the GFCI, because there is a return path on a ground fault condition, it will allow that GFCI to function adequately as well, okay? So these are all good things. So that's why you want to have a neutral bonded system, okay? Neutral bonded generator. All right, so let's kind of look at the path of what happens when you have a generator that does not have the bonding. Okay, so here's a generator, portable generator. It's unbonded. So this is the floating neutral or type of generator. So we don't have any connection from here, okay, over to the frame. Okay, we don't have it. So here's our GFCI receptacle. Here's our load that's going to plug into it right here, just plugging in. And now we have this ground fault. All right, we have this ground fault. So current is going to be passing through here, stops right here onto the frame, right? You're still going to have your load that's going to pass through the load. The GFCI is not going to function. The overcurrent device here is not going to function. In fact, this frame could sit energized, right? All of that, okay? That's a problem. The moment that you throw in this jumper, and this becomes a bonded generator, now that fault current gets back to the source, skyrockets at the fault, and that's what clears the overcurrent protective device quickly, okay? That type of thing. Also, because you're looking for the return path outside of the GFCI, if it gets back here and stops right here, it's not getting here to create that imbalance. So the GFCI will not pick up on that and will not function, okay? So that becomes a problem as well. Now, let's read a little further. It says, the designation as a separately derived system, okay, so that's what a portable generator is with the bonding jumper on it, okay? So we're having it from the neutral point over to the frame. That would be standalone. That's a separately derived system, okay? It requires a neutral and equipment grounding conductor to be bonded to the frame of the generator. We all agree. And the transfer equipment to switch all conductors That is so important. So if I use a generator, portable generator, and I just go buy a bonded generator that's a separately derived system, and I go install it at my house, okay? Now what I've got is what? I've got a transfer switch. If I'm not going to switch all of the conductors, even the neutral, then the problem is I've got a separately derived system that I'm being placed on a system, and I've got a problem here, okay? The problem is if I don't switch the neutral through transfer equipment, now I've got parallel paths, right? So this designation and switching arrangement where you do switch the neutral on a separately derived system like that generator with that bond in it, okay, then it prevents parallel current, right? It prevents this arrangement. And what it does is it prevents neutral from being in parallel with the equipment grounding conductor since it is required to be switched in the transfer equipment. Why is this so important? Well, a lot of times when you order, generators, and let's say whole house generators, is kind of talking about separately derived systems. When you order a residential, not talking portable now, but we'd say you order a residential generator, whether it's Generac, Kohler, whatever the manufacturer may be, you have to look at the transfer equipment because it could come with that bonding jumper in it, system bonding jumper already installed. It could come with that. But yet the transfer equipment is not switching the neutral. Well, that's a problem because it allows circulating currents to go back through the generator from the service back through, and since at the generator, the neutral is connected to the frame and also the equipment ground, it allows for parallel paths of that neutral current to travel, right? And so that means that metal parts can become energized, right? It's part of that neutral path. So that's an unsafe condition. So you have to be careful. So if you did have that, then it is separately derived. Now you have to look at a transfer switch and you need to make sure you're switching the neutral so that you break that path. When the service is being running, you're breaking it. All of the circuit conductors, not just the hots, but even the neutral are being broken. And that scenario is. And so think of it this way. If you're not breaking it at the generator, then you have to break it at the transfer switch. Otherwise, you get these circulating currents and these parallel paths of neutral current. It creates problems, circulating currents and all these kind of issues. So the transfer switch is critically important for that aspect, right? Okay. I'm going to make sure that we at least hammer that home, that switching of the neutral is very important determining whether or not your generator is separately derived or not, okay? It plays a critical role in that. Now let's talk a little bit more. It says the neutral or frame of the portable generator is not required to be connected to grounding electrode, and we talked about this, as long as all power loads are supplied from receptacles mounted on the generator, okay? So the neutral or frame of a portable generator is not required to be connected to any electrode. We saw that. That was the very first thing that we looked at. Not required. If all the load is supplied through receptacles that are mounted on the generator or the actual equipment associated with that generator is mounted on that actual generator, okay? Now, because the neutral and equipment grounding conductor are connected to the frame, as required in 250.34c, overcurrent protection and GFCI protection on the generator will function correctly. Okay, so this is a generator where you have the bonding jumper in it. Everything's bonded. Okay, the equipment ground terminals for the receptacle is intimate with the metal framing of the generator, which is intimate with the neutral point on the windings of the generator. If that's all done, and all the receptacles supplying the loads are cord and plug on the generator, or the equipment itself that's supplied by the generator is on the generator, then I do not have to have any electrodes. We've already established that, right? Okay. So we're going to look at another figure real quick, and this is when we're talking about things like transfer switches for generators, portable generators. Okay. All right. Figure 2-72. That's this one down here. It says shows the type of transfer equipment that is often installed to provide the supply of a portion of a premise wiring system by a flexible cord from a portable or vehicle-mounted generator. Okay, so this is the inlet. Okay, and this is a transfer switch that would be utilized. One of them that would be utilized. It says the flanged inlet receptacle provided for the flexible cord connection. Circuits to be supplied have been connected through the transfer equipment and are selected by rocker type switches. So this is what we see right here. So here's the inlet, and it would go from here over to the generator, right? And these are your rocker switches that allow you to turn on the different circuits that are supplied through this small looks like six circuit transfer switch, okay? All right, so in looking at this transfer switch, and you can look in right here, here's your service equipment, okay? And right here, you've got your service equipment, you've got your main bonding jumper, everything's installed, and here's your electrode. So this is your service. And here's the receptacle right here. This piece right here is the actual depicting this receptacle, right? So here's what happens. Now, if you go buy a portable generator, okay, and in this case, this is one that is bonded, right? So this is bonded right here. So let me kind of blow this up if I can. Oops, that's not what I want. Let's see here. Trying to find out where I zoom in on this here. Let's see. There we go. That's about the best I can zoom in. All right, so here's what you got. Because this is connected together right here, right? You have to switch the neutral in this transfer equipment, right? Well, this is a problem because they don't switch the neutral. And then this piece of equipment, if you look inside of it, you see right here, the transfer equipment, and this is the inside of one of these back here, by the way. This is opened up, turned open. You'll notice that the neutral is not switched to prevent parallel path for neutral current. So if you're using a portable generator or a vehicle-mounted generator, that does have the bonding taking place in it, which is what you would use if it was a standalone, by the way. You're going to have to select a transfer equipment that does what? That actually switches and shuts off the neutral. Because if you don't do that, then it's going to create parallel paths for neutral current. And then, of course, then all these bonded connections are now going to be energized with neutral current. So critical to not just buy components, put them in, buy a generator, and not know what your application is for. So typically, a floating neutral generator would be what you would use on a dwelling, whereas a bonded type generator is what we would want to use as a standalone application, okay? And now I'm not going to get into modifying generators. We'll leave that for you to search out and find for yourself. I'm not going to get into that liability trying to explain that here. But okay, just be careful and realize that if you're going to use a generator that has the neutral connected to the frame, which is what you would use in a standalone, that if you're going to use it in this scenario, you need to what? You need to switch the neutral. And the sad thing is, when you're buying transfer equipment, it doesn't necessarily always come with the generator. So you got to be careful what you buy. You got to know what you're buying. And again, you can create a serious issue if you don't know what you're buying. Okay. All right. Now, the drawing in the middle of figure 2-72 shows a typical circuit where the portable or vehicle-mounted generator is connected to the premise wiring through this transfer equipment. Right? That's very typical. This right here is very common. People buy them every day of the week as transfer equipment. Right? Because the equipment grounding conductor and the neutral are connected together at the service and at the generator, neutral current will be in parallel with the equipment grounding conductor. Okay? So the lower picture shows the inside of the transfer equipment shown in the upper photo. As can be seen, the neutral connection is not switched. That is a serious hazard. All right? That means this neutral current, even in this service, when it's back to a service, that it can actually send neutral current back through, over through the winding, back through here, and then back on the equipment ground. Creates a loop. Okay? So it creates a very unsafe condition. Right? So either you're going to break it here at the generator, right? And if you do it here, then that's where typically you don't need to break it. You can use a solid bus type transfer equipment. But if you're going to connect it over here, then you're going to have to, and this creates a separately derived system here, then you need to switch the neutral. Okay? You need to break that cycle of paralleling the neutral like that and creating that circulating current. It's all going to hinge mainly on your transfer equipment. Okay? So, doesn't mean I can't use a generator like this, but I have to make sure that my transfer equipment accommodates that. Okay? All right, folks, let's bring it back to me. So the moral of the story here is, if I'm going to use a generator for construction site, camping, as a standalone, separately derived system, I don't need grounding electrodes for it as long as I meet those conditions. Either the equipment or the receptacles are mounted on the generator and it's cord and plug type of application, then I don't need grounding electrodes. Okay? I don't want to use a floating neutral generator in a standalone application. Okay? If I do use a portable generator to supply power to a dwelling, then I want to make sure that if it is a bonded generator, that I have a transfer switch that switches a neutral. If I'm using a floating neutral generator, then it's okay for me to have a transfer switch that is solidly connected, not switching the neutral. But again, you only want to use the floating ones on a premise application, because we just saw what happens if you use it as a standalone. The GFCIs won't function and the overcurrent device likely won't function, so that becomes a safety hazard as well. Moral of the story, think about the generators you purchase and the application that you're using them for. If you are truly going to use it just for portable needs, right, then do me a favor. If that's the application you're going to be using it for, get a generator that has a bonded neutral and use it for those portable applications. All right? Okay, folks, we'll go in depth in other applications from generators, interlocks, and all this kind of stuff, and the feasibility of those in a later episode. Till next time, folks, stay safe. God bless. Hey folks, Paul Abernathy here. Thanks for joining me today. Today we're going to be looking at emergency disconnects. Now, the emergency disconnects when it comes to 1 and 2 family dwellings came into the code in the 2020 edition of the National Electrical Code. Of course, it was discussed during the 2017 cycle, but it just didn't get enough support. Even with a lot of the firefighters, emergency responders behind it, it didn't get enough support. But in the 2020, it came into the code. And here we are now in the 2023 edition of the National Electrical Code. And we want to examine it so that everybody is fully aware of what is required for these emergency disconnects. And we want to show a couple examples because a lot of people seem to be confused. Now, will the requirement for the emergency disconnect bring in some additional costs to the consumer? Absolutely. But this is all in safety for the first responders, people that are coming to structures, to be able to, remember, 1 and 2 family, the most predominant that we have, where people are sleeping or not aware of their environment and what's going on. And of course, first responders have to respond. And We don't want them going into houses searching for ways to cut the power off. We also don't want them hacking up the service conductors or the meter or trying to pull a meter. They're not electrical experts, so we don't really want them to be working with those energized live parts that typically are not going to have any overcurrent protection ahead of them. So it creates a safety concern. So that was the justification for why it made it into the National Electrical Code. Now, 2023 edition of the NEC expanded a little bit, added a replacement requirement, added some marking requirements, a little clarification. And if you have other power sources, energy sources to the building, like PV or a generator, and maybe their disconnect is somewhere else, it's not grouped with the emergency disconnect location, then you're going to have to put a placard or directory telling people where that is. So we're going to look at that. So we want to make sure that we keep all those things in perspective. So let's go on and go to the National Electrical Code. So here's the NEC, and we're going to be looking again right here at 230.85. This is the emergency disconnect requirement. As you can see, it's 1 and 2 family dwelling only, so that's all it applies to. And it is an emergency disconnect, means it shall be installed. So it's not an option for you to not do it. You're going to have to install an emergency disconnect if it's a 1 and 2 family dwelling unit. Now, in the 2020 edition of the NEC, there was only 230.85, 1, 2, and 3, and they're still covered here. There's no change as far as that's concerned of your options. It's just in the 2023, it's a little bit more clarity. You now have broken down into subparts A, B, C, D, and E that kind of break it out a little bit. Instead of it being all lumped into one code rule, it's been broken out a little bit for clarity. So let's look at it. We're in the 2023. So we're going to have the general requirements. We're going to have the disconnect itself requirements, and we're going to look at some examples of these. And then you've got replacement requirement that is new for the 2023. So again, and there's an exception because, you do have occasions where you have storms, hurricanes, any damage that might damage the meter socket itself, the meter enclosure, maybe the service conductors that are coming from the point of attachment down. So, or what's coming up, something might have happened, but you're not replacing the entire service. Then we do have some exceptions here that you can kind of go back and put it back the way it originally was. So good to have some of those exceptions. We do have this new rule for identification of isolated disconnects. This is an example where you have your emergency disconnect for the service, or where you're coming into the building, the emergency disconnect. You do have where you might have a PV or a generator isolated disconnect somewhere else on the structure. It's not grouped here. So if that's the case and it's another power source, then you have to have a placard or a directory letting the first responders know right here at the emergency disconnect where those other disconnects are located. Okay, makes sense? So that's a placard. It's got to withstand the elements. It's got to meet all the requirements of to be, if it's raining or whatnot. So people know, the first responders know where to go. Okay. And then of course we have the overall marking requirements. And this is going to tell you what, if it's a service disconnect, what you got to put on it. If it's a meter disconnect, then here's what you got to put on it. And if it's a other listed disconnect, which we're going to look at, which is the costly method, but that is another option that you can have for that, and tells you what markings have to be on that as well. So here are your markings, depending on which one you're working with, right? You're down here. And we also have the location where it's to be marked. Now it's very clear that this new language, that the markings have to be on the outside cover. So it can't be inside the cover, hidden away. It's got to be seen. It has to have a red background with white letters. It has to be at least a ½ inch high. So it's got to either say any of these. And we'll look at each one of these so we know clearly what our markings have to be. But we're kind of dipping our toe in here. And for you that are just coming into the 2020, this is basically a deeper breakdown. But in the 2020 edition, it's basically just going to tell you that it has to be readily accessible outside. Okay, you're going to get your 3 options of disconnects, and we're going to look at that. It's going to be the same in 2020 as 2023 when it comes to that. A little more language clarity in 2023. But we're not here to look at the 2020. We're here to look at the 2023. So Let's do that. So let's go back up here. So the very first thing, let's talk about location. So where does this emergency disconnect need to be on these 1 and 2 families? And it says right here, for 1 and 2 family dwelling units, an emergency disconnect means shall be installed. So it's not an option. It shall be done in 1 and 2 family. Now, a couple ways to comply with this. And again, this has to do with first responders, emergency responders. We do not want them trying to cut the service conductors. We don't want them trying to pull the meter or anything like that. Creates an exposure. They're in this exposure area, and we don't know if it's raining, there's spraying water everywhere. We don't know what the condition. It's not a safe condition for them to be able to shut power off. And I don't want them forging through the structure if it's involved, in a fire or something's going on, and try to find out where the breaker is to shut power. It's just not a safe condition for them. So there's many people that don't like this rule because they puts the emergency disconnect outside. People could shut off power to their house and things like that, and it frightens them. But you can lock it out. If you go look at the definition of readily accessible, it needs to be readily accessible to those that need ready access. So locking it behind a cover still makes it readily accessible to those that need to get there. As far as the operation of the overcurrent protective devices, they're going to operate anyway because they're going to do their job. You hope so. So not really that too much that somebody should be too awful concerned. In a lot of parts of the country, they put the disconnects outside anyway. Whether it's the service disconnect, that could also serve as the emergency disconnect. They already do that. But we'll talk about some issues that can generate as well. So, all right, so let's look at here. So locations, where we got to have this emergency disconnect. All right, here's the location. It says the disconnecting means shall be installed in a readily accessible location, outdoors, on or within sight of the dwelling. Okay, so on it or within sight. What is within sight? Within 50 feet line of sight, so you can see it. Okay. Now there is an exception. Now this exception did not exist in the 2020 edition, and this is important because let's say that my service is coming down for this one family dwelling and it's remote and it's going to change over to a feeder. I mean, this is very common. I did this quite a few times on houses that back in the day, they did not want everything on the side of the house and we put it remotely, and long story, but we would come underground, change over to feeders, and now feeders would supply the building. Well, in the 2020 code, the emergency disconnect, if you did that and you took the feeder to the structure or the building, then the emergency disconnect would not be at the building. So if a first responder came, they absolutely wouldn't know that possibly they wouldn't see anything. So they'd have to go hunting for where this would be. And so in the 2023 edition, they added 225.41. Now I can add that here so you can see it. It basically has to do with the feeder. If that's your choice, you're not bringing the service, but now a feeder's coming to supply the 1 or 2 family dwelling, then it's basically the same rules, okay? Basically the same rules, but now it applies to that feeder supplied emergency disconnect, okay? So that was added in the 2023 to kind of accommodate that issue where, okay, well, I don't have the service conductors coming to the building and I still have the same hazard. And somebody might not know where that service equipment is, so or the emergency disconnect is at that point. So at this point, what about putting it at the structure? So that's where this one came in. So that's what 225.41. Now, if you're using 225.41, then this location rule doesn't apply. None of that applies because you're doing it to the feeder, and you're skipping this one, and you're actually doing it with 225.41 for the feeder. Makes sense? So if you're bringing a feeder to the building, then you're going to be shifting to 225.41 for that emergency disconnect, okay? And ignoring this. Okay. Now, assuming we're back at the emergency disconnect, just where we got service conductors coming down from the point of attachment or under from a service lateral. Next is the rating. So that disconnecting means, and you notice that it goes out of its way just to say disconnecting means. It's not saying service disconnect, it's just saying disconnecting means. It says, okay, the disconnecting means shall have short circuit current rating, that's SCCR, equal to or greater than the available fault current. So typically for residential, they usually try to guarantee it. It's not going to exceed 10,000. So AIC. But you know what? Check with your jurisdiction. Look at what you're doing with. Just make sure that the disconnect that you choose is equal to or greater than whatever they give you as the available fault current. And typically we get that from the utility. They supply that information. So just make sure that you have that. Or they might give you and say, we guarantee that we'll never exceed 10,000. And then you make sure your equipment's at least that or greater, then you should be okay with that. Okay, but again, that's something you have to check with your local jurisdiction and local utility. Next, as far as grouping it, if more than one disconnect mean is provided, they shall be grouped. So another grouping application where we're trying to get them grouped here for this application. Again, very critical if we're talking about something like a two-family dwelling, but here we want everything to be grouped, right? Now, next we get into what's called the disconnects. Now this is pretty much mirrored on what you had in the 2020. So the other stuff was kind of in the language itself in the 2020 edition of this in 230.85. It was all written in the verbiage, so you had to pull it out. So all they really did was extract it out and put it into this kind of format. That's all that really took place. Now, the disconnecting rules, which the different types of disconnects that you can have. Now, the first one being a service disconnect. And that service disconnect could serve as the emergency disconnect and the service disconnect. So what are your options here? Well, in many parts of the country where they put the whole panel outside, it's got a main breaker, and that's your disconnect. That'll be the emergency disconnect. Plus, it is also going to be the service disconnect. It's going to provide overload protection to those service conductors. Okay, it's not going to provide any short circuit ground fault protection, but it's overload protection, which is required by 230.90. So it's meeting that. And then everything after it, you have all your breakers. Okay, they're basically going to have your breakers, and then you'll have your branch circuits coming out of it. All right, so that could be your service disconnect, and that's going to be your service equipment, and it's going to be your emergency disconnect. And he'll show you what you got to do to label it here in a minute, if it is, that's what it is. Now, that's probably what people do with the NEMA 3R exterior panel board type of application, right? Well, another option is to simply put a main breaker, 200 amp, let's just say it's 200 amp, a 200 amp disconnect outside. That is also the service disconnect, but it's also the emergency disconnect. And I don't have all the breakers in there. It's just one main breaker. Now, once you come out the load side of that, that's a feeder. And the feeder is going to supply the rest of the building. So let's kind of look at what one of those would look like. And this is how I would do it. Now, is that going to add some additional cost to the install? Well, of course it is. But again, I'm going to get rid of a lot of problems that people have by putting the exterior NEMA 3R, and then you got to worry about how do you get those cables into it. And if it's installed on the side of a building and it's got that 1/4 inch gap in 312.2, then how do I transition and meet the code? I mean, obviously, we've talked about this, 312.5C1, you can't take all the non-metallic sheet cables through one knockout. That's not compliant. And if you were to try to punch holes in it, you can't take all of those NM cables out the building, and then that small little 1/4 inch gap is going to put you in a wet location, so you can't install NM cable there. So it makes it more complicated to do this compliant. Whether somebody allows something or not, it makes it more complicated. So I'm like, okay, well, I want to make my life easier. Plus, you know me, I don't like the breakers being on the outside. You may love it. Your state might be all you do. I don't like it personally. So I'm an electrician, my choice. I'm not going to do that. So what am I going to do? I'm going to go this route. So I'm going to get me, and it's no particular brand. I just picked one. You know, this one happens to be a Siemens, a great company. Speaking of a plug, in a couple months, Vince Delacroce, who actually is the code expert for Siemens, is going to be coming here to the studio, and we're going to be doing swimming pools, spas, all the changes for 2023. It's going to be awesome. He's going to be with me again, and we're going to redo that entire series, and it's going to be awesome. So I'm looking forward to Vince joining me here at the studio so we can get that all done. All right, so let's look right here. So here we go. This is an outdoor main breaker, as you can see right here. Okay, there you go. It's just a 200 amp. That's it. And when you look inside of it, I'll give you a little sneak peek here. As you can see right here, you've got the service conductors come into the lugs, and then the load side at the bottom is where your feeders are going to come out and going to supply a panel, either inside, just inside, or maybe even somewhere else in the structure, right? But this is the only thing outside. Now, this is the service disconnect. Now, if you look over here on the right, and I can't, right here where my mouse is, although I'll try to move it a little bit to the right. So right here, you move it to the right. See there, it's got that hole. So that is where you're going to put your main bonding jumper. And this is the service. It's suitable for use as service. And this is going to be my service equipment. It's going to be my service disconnect, my emergency disconnect, and then it's going to create a feeder on the load side of it. Okay. And that's going to feed my panel somewhere else, which could be main lug only if I want, because I've got the protection upstream. All right, so, and of course that might save you cost-wise because you don't need another main breaker. Now, if you want to get a panel with the main breaker because of cost and supply, that's okay too. You can have two. That one's just going to be basically a switch, even though it's probably still going to have an overcurrent rating on it, but you get my point. This is an option that I would go with. I'd install this on the outside, turn it into a feeder, and I can put my panel anywhere I want inside that dwelling. If they still want it on the other side of the wall, that's fine. But I don't have a limitation on how far my feeder can go. But I do have limitations on how far service conductors can go inside of the building, okay? 230.70A1. So at this point, this is what I would do, right? So this is a service disconnect. It's just one 200 amp breaker. Yes, okay, cost, right? Because everybody saw the cost here. An additional 174. Prices are going to vary from different manufacturers. This is Siemens. I think this is just purely, I think this was at Home Depot. I might have gotten where I got this example from. But this is just one option, okay? So keep that in mind. This is just one option to be aware of. And you really can't see the label, but on this label, it says suitable for use as service equipment. But there's something important about it. It does not say on it suitable for use only as service equipment, because it has the ability to remove the main bonding jumper, that connection to the grounded conductor, right? So that's important. We'll see that a little bit later when we're talking about the different options for disconnect. So this is the first one. This is what I would use as a service disconnect for me. Now, again, you could put an NEMA 3R panel with a main breaker and breakers in it. That's your option. It's just more difficult to figure out how I'm going to get my cables into it, right, than something like this. So an additional $174, I don't have to worry about it. I just take some SER on the load side of this thing in and hit a panel, and then I don't have any problems, okay? I'm willing to pay $174 to not worry about the headache. And I want the panel where I want it. For me, I just don't like it outside. You may love it outside. That's just not me. That's the beautiful thing about it, right? To each his own. Okay, so let's kind of look at the next option. So the next option is a meter disconnect that is integral to a meter-mounted equipment not marked as suitable only for use as service equipment, installed in accordance with 230.82. So I could have a meter disconnect that is integral to the meter mount equipment. So it's all integral, and it is really just a meter disconnect. That is it. Right? Now, don't confuse the meter disconnect with a bypass, right? If you go to Millbank, you can learn a lot about the difference between a disconnect and a bypass. A bypass is designed to be able to just interrupt to the point to take out the meter, but it doesn't interrupt power to the dwelling. It's just so they can remove power from the meter so they can safely remove it. That is not a disconnect. It's not intended to be a disconnect. So just because it might have that lever. Now, you can buy equipment that is a lever or what we call a hook style that you can use that basically is the bypass. And you can buy bypasses that also have integral meter disconnects in them, right? So they can bypass it and not have to disconnect, but still remove the meter. Check with your supplier of your meter, but again, this one is not the one that I recommend unless the power company is going to supply it with it, give it to you. All right. Now, you might be in the parts of the country where it's all integral, And chances are, if it is, then you're going to have a meter with maybe a bypass, but it's also going to have an actual meter disconnect in it. Now, that may or may not also be service equipment. It depends on the meter, depends on the assembly, the combo. It might have a main breaker, and it might say in it that it's suitable for use as service equipment, and it might have breakers underneath it. Okay? That is all dependent on what you buy. All this rule is saying is if you have a meter disconnect and it's part of a meter mount equipment, if it is just a meter disconnect, it is not service equipment. Okay? And why is that significant to us? Because with that service disconnect one we just explained a little bit ago, once it gets on the load side, it's now a feeder. So you have 4 conductors. You'll have an equipment grounding conductor, right? Because now we have a breaker that we could trip, that 200 amp on the load side. With the meter disconnect, it is not, okay? It is not going to be service equipment for just a meter disconnect. Now, again, you can buy combos that are more than just a meter disconnect, but we're just talking about a meter disconnect, folks. That's all we're talking about. And it says it very clear right here. It says a meter disconnect integral to the meter mounting equipment, not marked as suitable only for use as service equipment. So we don't want it to be marked that it is only to be used as service equipment, okay? That's not what you want because we're not using it as service equipment, right? And then when it makes reference to 230.82, the whole intent of that is it's going to be on the supply side of the service disconnect. That's the whole nature of 230.82, right? So that makes sense. So it's not a service. And we have to mark it accordingly, and we'll look at how you mark it here later. Now, the next one is, to me, the most costly. I'm going with that service disconnect like I showed you. It's $173. I'm going with that. There are other listed disconnect switches, circuit breakers that are marked suitable for use as service equipment, so it has to have that marked in it, and most of them will, even a lot of those safety switches will, that say it's suitable for use. But it cannot be marked as only suitable for use as service equipment, okay? Very important. We have to make sure that it has to be marked suitable for use as service equipment, but it can't say that it is only to be used as service equipment because we're not using it as service equipment. We want the ratings. We want to make sure it is SUSE rated, but we're not going to use it for service in this case, all right? Okay, makes sense? And also you got some information on, and it reminds us again that with all that said and done, it reminds us again that it's being installed on the supply side of the service disconnect. So we know that it's not the service equipment, and we're going to have to mark it accordingly. So you have these 3 different offerings. So what does this kind of switch look like? What are we looking for? All right, let's kind of look here. So here's another one. We're going to stay with Siemens brand since we're working on this. So here is a 200 amp, 240 volt, 2-pole, non-fusible safety switch. All right, here's what it looks like, and here's what your labels look like. And this is, again, this is here you see it. It's a safety switch. It's non-fusible. It's listed. And remember what we said? So here it is, the label on it. Notice, look at the top. And I will try to make sure I can get over here so you can see it. Where my mouse is, right here. Let's look at it right here. See what it says right here? Suitable for use as service equipment, right? Right there. All right, now, why is that important? Well, because that's what it said. I could use this switch. And remember, it's non-fused. So it's not providing any overload protection that's required by 230.90. It's just a switch. It's just the emergency disconnect. And so, again, that's what it kind of looks like inside. And that's all it's serving. It does not say on it anywhere that it's suitable only for use as service equipment. It doesn't say that. So I can use this one here. Now, the difference in why I'm not going to use this one, for me, is that price right there. Why the hell would I do that for $173? I can just go in and kill 2 birds with 1 stone. I get a service disconnect and emergency disconnect. And so this is just an example, right? Notice it says suitable for use as service equipment, okay? All this kind of stuff. So at the end of the day, this is a non-fused safety switch, which is a listed switch, right? So we come back, and it is, again, it is other listed disconnect, switch, or circuit breaker. In this case, just the switch. Perfectly okay, meets all the requirements, doesn't say that it's suitable only for use, but it does meet the SUSE rating. It states that very clearly. I could use this. So this is an example of B3 if you want to do it. Again, my choice, and please don't let me sway you. I'm going with this one, and I'm going with that 173, service disconnect and emergency disconnect combo. And I'm going to change over to feeders, and I'm going to put my panel inside where it's easy for me to get cables to it. I don't have to worry about trying to get outside and all that kind of other stuff. So that's how I'm going to do it. All right, now replacement. So in the 2023 edition, we now have a replacement rule. It says where the service equipment is replaced, all of the requirements of this section shall apply. So we have a retroactive rule here, whereas if you're going to replace the service, upgrade the service for any reason, then we're going to have to meet this rule and put this, again, 1 and 2 family only, we're going to have to put this emergency disconnect in. And I've got my options, as you saw, different options to do this. But there is an exception, as we talked about earlier. If I'm only going to replace the meter socket, or I'm just going to replace the service conductors that are coming down, or I'm replacing the raceways or fittings that are associated with those service conductors and all that, basically maybe in a storm or tree has fallen or something happened, but I'm not replacing the panel, I'm not doing any upgrade there, then I'm okay to put it back the way it was. That's basically what this is saying, that under the exception, right? But if I'm going to replace the service, then then the exception's not going to apply, and I'm going to have to replace it. Now, here is the identification rule that we talked about. I touched on it at the beginning briefly. It says where equipment for isolation of other energy sources, and again, it gives you some reference down here in the informational notes. That's why I love informational notes, by the way, is they should give you information, not enforceable, but give you like roadmaps to other relevant things in the NEC. So it's talking about generators and things like that, battery systems, interconnected power sources and 705 and whatnot. So if I had a PV or I had a generator or I had something else with their disconnecting mean requirements, and it wasn't located right here where my emergency disconnect is, then again, this is where I have to put the placard or directory directing the first responders to wherever that other energy source disconnect is, so that they can shut it off. That's the last thing we want to do, is have them shut off the power and then the generator kick in and re-energize everything. Because you remember, they're coming to the structure, they don't know what the hell's in there. They don't know what's going on. They're not electrical experts. So again, this is just a safety thing, and it makes sense. So if they see a directory, then they know, oh wait, we got other things we got to shut off. Makes sense? And that's the whole purpose there behind that. So this is kind of paraphrase that one for you. Feel free to pause and read it if you want. And lastly, that's these markings. Now, before we told you in the 2020 that we had to go back and look at 110.21b, and that's legibleness, and has to be designed to handle the environment to where it's installed. Wet location, you're obviously not going to use labels that are inkjet or easily going to be smeared or going to be become illegible. So we have to think like phenolic labels, metal painted, screen printed type of labels, whatever. We have to start thinking of something that's going to be there on the outside of the cover so that anybody could see it. So let's talk about that. Now let's look at the markings. Now we told you the different types of disconnects, right, that we have. So if we went with our service disconnect option, whether that was the one I told you about, the single breaker outside and the single enclosure, or a NEMA 3R panel with a main breaker and breakers, however your flavor, then we have to put the markings emergency disconnect, because that's what it is, meeting 23085. But if it's also the service disconnect for the dwelling, then that is also got to be marked on there as well. Now, if we chose the meter disconnect option that is permitted by 230.82.3, then I have to label it as an emergency disconnect. I have to label it as a meter disconnect, very clearly that it's a meter disconnect, and it's not service equipment. It is not considered a service, just like a meter enclosure is not considered a service. All of that. Now, I'll remind you that all this is also regurgitated in 230.82.3. If you go read it, it's all regurgitated again. Remember, the whole intent of 230.82 is to be on the supply side of the service disconnect. Thus, the meter disconnect can't be a service disconnect. so we have to mark it as such, right? It has to have all of these things on it. Now, the last one was that example of that expensive switch that we told you about, non-fusible, okay, is an example that you could use. Could be a circuit breaker style. They do make circuit breakers that don't have overcurrent rating. They're just simply nothing more than a switch, okay? Now, with this one, it has to be marked emergency disconnect, and it has to make it very clear that this is not service equipment, right? It's not. If you have 3 conductors coming into it, through the meter, into this switch, 3 conductors are going to continue on. They're not feeders based on this configuration, all right? Because it says, okay, that it's not used as service equipment, all right? All right? All right. Now, what about the marking? All this you see here is exactly what you're going to print on these labels or these little markers, okay? Down here, it's the location and the size. So right here, it says this marking or label shall be located on the outside front of the disconnect enclosure with red background and white letters. So you get these pre-made. You're not going to do it in a Sharpie. Again, 110.21b is going to say it's got to be, it can't be handwritten, so that's not going to work for you. It's got to have a red background, white letters, and those letters have to be at least a ½ inch high. So we're taking a little cue here from fire alarm circuits and everything in 760. So it's got to be red background, white letters, at least a ½ inch high outside of the disconnect so that anybody going up to it can see it. We know exactly what's going on, okay? So that's what we've got in this application. So that's your changes to 230.85. I think it's a great change. I think that it really solidifies why we need this emergency disconnect. And again, 2020 was a great start. It kind of tells you everything you need. But in the 2023, it's just, you know, people ask why. Let me come back to me real quick. People ask, why do we change every 3 years? Because a lot of times, have you ever written something and then you look at it and you go, you know, I can say this a little better, or we can be a little clearer. And then you got to, once it's through the process, you don't catch everything. So then they're like, oh, let's take another stab at this and make it even better. And that's what happens. And then people all over the country, experts like Fred Hartwell, who is really into this type of thing, you know, people like that who are experts in the industry, and even you out there who have your knowledge, maybe you have extra knowledge in certain things like this. Maybe you're the firefighters and you really know that this can save lives, especially to the firefighters, first responders. Then you're able to submit something to modify it or change it to make it sound better, make it be a little easier flow. That's what we're after. So it's not about people just trying to get things into the code. Sometimes clarity is needed to make something easier to understand. And that's the case here with the 230.85. All right? Okay, hopefully you got something out of it and I didn't bore you to death. Hopefully you follow us on all of our social media platforms. If you need a good electrical code class online, go to fasttracksystem.com. If you want to see a lot of our videos, then you got to go to Fast Tracks Tube. Fast Tracks Tube. Take the system here and replace it with tube.com, and you can get all of our exclusive videos. Make sure you become a subscriber. We'd love to have you. Again, thank you for watching. Until next time, folks, stay safe. God bless. Hey folks, Paul Abernathy here. Welcome back to another video. If you like our videos, do me a favor. You've seen them in the past, or your expectation that I'm here to bring you great content. Do me a favor. Consider giving us a like and sharing our videos with other people. It really helps. And again, don't forget to subscribe to whatever platform you're listening to or watching on, because it does help us out and allow other people to find out about our products. Remember, we don't advertise on ad sharing platforms. We are organic, and people come to us because they love our training, whether it's our Fast Tracks program or some educational videos that we have over on fasttrackstube.com, which is our exclusive video platform. Okay, we're going to do a little bit of exam prep today, kind of look at a couple questions, kind of dissect them, and I'll give you some tips along the way. One thing about when I explain the National Electrical Code, I'm not just showing you questions and just letting you guess the question. I'm an educator. I've been doing this for over 32 years. I like to show you where it is in the code, take you there, let you see it, and kind of get a feel for how you get there. Now, one of the downsides to our online is that we don't have an index. So one thing I encourage you to do is get used to using the index if you're preparing for an electrical exam. Take your index, look at a question, dissect the root of that question, and we have a video on that, how to dissect the root. It's available to our Fast Track students in our program, and it kind of teaches you how to look at a question, okay? All right, let's go look at a couple questions, and we'll see how we dissect it. And what we're going to be using today is the latest addition to our database of questions. So we have in our Fast Tracks programs, the Black and the Plus program, we have over 1,200 exam style questions, and that's the competency review and the practice questions. But we added another 700 plus questions to our database for you. More resources. That's what makes our program so affordable, because of what all you get. And you get access to me. So that's a difference too, because once you become a student of mine, you always have me just one click away. If you get our mobile app on your phone, then you always have access to me. There's a neat chat now feature where you can ask me any question on a job site. I am your consultant in your pocket, and that's another reason we never leave you hanging. All right? Okay. Enough of the sales pitch. Let me get you to the code question. All right. First code question we're going to look at here is, again, if you're taking an exam, there's certain things that you'll know. There's certain things that'll stand out here. You're not going to be able to use the index to answer every question. We already get that. You should know that by now. The reason that our course is so popular is because we walk you through the very beginning all the way through 19 units. So a lot of times, the questions you might see on the exam, you won't need to go to the index because you'll just know it right off of your studying. That's why we do it that way. A lot of programs, and I'm not selling you, I'm just telling you facts. A lot of programs will give you nothing but code questions. And they really aren't designed for exam prep. And they certainly don't meet the threshold of what we created in the Fast Track system, which is, again, federally protected, trademarked type of program that really leads you through. I mean, Fast Tracks is a protected mark, and it's all built around our educational system. We want to teach you from the beginning all the way up through special occupancies, special equipment, all those type of things, but we're going to drip feed you every unit. Okay, so this is extra questions. These are over and above that we're going to give you in the database. So that's what we're looking at today. Oh, by the way, the Fast Tracks is available in 2017, 2020, and 2023. You do not get these bonus questions in the 2017, only the 2020 and 2023. Sorry. Okay, all right, so let's look at the question. All right, so the question says a minimum size for a single conductor used for power limited fire alarm, okay, so PLFA circuits shall be blank AWG. So the first thing that you'll know if you're an astute studier of the NEC is that you need to dissect where we're looking. Well, obviously we're looking for conductor sizes, but where is it specific to? Fire alarm. What article in the National Electrical Code focuses on fire alarm? Now, we're not talking about NFPA 72, we're talking about what's germane to the NEC. And we know that Article 760 is focused on it. Now, Two ways to find this if you didn't know, but you knew the target here, the root is we're dealing with fire alarm circuits, in this case, power limited. Then you could go to the front of the table of contents and look at the different articles, and you'll find 760. You could go back to the index and look under fire alarm, and you'll find something there that'll get you to 760, and maybe even talk about the circuits and minimum size. But you got to remember that some articles are fairly small, and 760 is one of those. It's not overly extensive, so what we use is a technique called bold scanning. And so we're going to go to 760. Now, I'm going to be using Link. Y'all all know how I love to promote Link. I think it's one of the best things that NFPA has done when it comes to bringing the code book to your fingertips. So again, I have another video on that. Go recommend you watch it over on our YouTube channel. It's available. But let's go on and go to Link. And here I am in Link, and I want to get us to 760. Remember, it's fire alarms, so the trigger is you need to understand that when it asks about fire alarms, this is why I tell you in our course, you guys have heard me say this before, we have what's called flashcards, electronic. You should be making a flashcard on every article so that you can just flip it and know exactly what it is. 430 motors, 210 branch circuits, 215 feeders, 225 outside branch and feeder circuits. You should be just knowing these things. And by simply being able to go with it, 334 non-metallic sheath cable, again, 336 tray cable, 338 surface entrance cable, you should get fluid in all these type of things. It's going to make your life so much easier on exam, and you can make it fun because flashcards can be fun. All right, so let's look here. I'm going to get us to 760 in the code. And again, I'm using Link for those that want to know. So here we go. Here's article 760 fire alarm. Now I want to show you it's not that big. It jumps pretty quickly up in numbers. So as you can see, it jumps up, right, to 735. Now you could probably go to the index and get a little more detail. In fact, let me do that just because I don't have it available in the program. But if I have my code book, remember what our question is. It's the minimum size of the power limited. So if I were to go to my index and I just say here, the trigger, let's go to fire alarm. And I'm going to do that. Do that with me. Pause the video if you want. Go to fire alarm and see what you've got. And see if there's anything in your index. And I'm going to go look. Okay, fire alarm systems. We see that. It tells us 760. And a quick look down this, you will see, let's go down. Okay, non-power limited circuits, 760 part 2. And then we see conductors, 760.49b. Okay. And I'm just going to keep looking to make sure. Power limited, and I guess our question was for power limited. You go down, you'll see power limited, not non-power limited, power limited. That was our question. And that is part 3. Now, under part 3, if you're following along in your code books, folks, under part 3, you see where the references are indented. That means they're germane to the power limited. And you go down and you'll see conductors size, 760.142, a great place to start. Now, we did this all really quickly if you're in an exam. The trigger was fire alarm circuits, and you know that it's power limited. So, boom, it was right there under fire alarm. So we're just going to go, save us a little time. We're going to go to 760.142. Okay, so I'm going to put the code book away, and we'll go to 760.142. And you're probably going to get there a lot quicker in the paperback version than you do in the electronic because you got to scroll, and I am refusing to use the search feature. Okay, so I went too far, so here we go. Right there. All right, and here was what it says. Let me go on and see if I can't zoom in a little bit for you. It says conductors. Let's see, conductors of 20, let's see here. Conductors of 26 AWG shall be permitted only where the splice, okay. And then it goes right here. It says, lastly, it says single conductors, and that's what we're talking about. Single conductor shall not be smaller than 18 gauge. Now, by the way, folks, this is another reason why Link is so good. Not for taking an exam. You got to have your code book. But interesting is it always gives you so a little bit of extra content down here, kind of just like a handbook in your pocket. It's awesome. But we see 18 inches. So we're going to come back to our question. You got all your options here. We'll click 18 inches. And we have a reference here. You click the reference again, 760.142, that's where we went. Now, I get people that ask me this all the time, folks. They will say, Paul, you only get 2 minutes, 2.5 minutes a question. Yeah, but when you're studying, you're not focusing on that. Again, relax. You're trying to dissect the question. You're trying to learn from the question how to use that index if there's something you just don't know. Now, if you're in our Fast Tracks program, you might have known that question right away, and you just answer it. You bought yourself a lot of time on an exam because it mounts up every time you answer something quickly. If you haven't watched our 3-wave method video, go check it out. Just search for 3-wave method on YouTube or Fast Tracks Tube. And in fact, it's free view over on Fast Tracks Tube if you want to get used to that platform, fasttrackstube.com. Okay, just like it says down here, except for system, it's tube.com. So go check it out. But if you are studying for an exam, take your time. It's not until the last 2 weeks that you need to worry about timing yourself. And the best way that you can time yourself is not to worry about the timers that are on the courses. It's to set your phone at 2.5 minutes or 2 minutes, depending on the number of questions on your exam and what it breaks down to. I like to just use 2 minutes because most exams are at least 2 minutes per question. Set your timer. And again, how you would do that is I would just go right into my phone. I go into my clock feature, right? And in your clock feature, right here, you have options. And I'm going to go to timer. Here's my timer. I'm going to set my timer for 2 minutes. Just like that. And I'm going to start that timer and I'm going to start answering that question. When I answer the question, I'm going to pause it. Okay, just click, where's the pause? The red button. Just pause it and see how quickly you answered it. Now, if it gets down below 2 minutes, it'll start alarming and go in the negative. Still keep trying to answer that question because now you want to see how much time over 2 minutes it took you. All right. So the reason I usually teach this technique, which is, again, you don't hear people talking about it. Everybody just says timer, timer, timer. Use the one that's online. Do all 100 questions. No, you need to do it question by question by question so that you can learn during this learning phase how to dissect a question. And then once you learn the key dissection, again, you get to learn the index. You get to learn the table of contents if that's where you're going to go. You get better at it. When it's time for an exam, it's going to raise your level of confidence, make you feel very comfortable at navigating this book, which is not the easiest book, whether you're tabbed out or not the easiest book in the world. So you don't need to be an expert on everything in the NEC, but you need to be very proficient in how you maneuver it. And that's what we try to teach you, right? Another question, let's go. All right, so this question here says a service has 500 kc mil conductors on a 400 amp service and we'll have a blank AWG supply side bonding jumper. Okay, so we know what the conductors are that are feeding the service, critically important. And you all know, and I teach this in my course, what are the 3 most important tables in Article 250 to remember or commit to memory? You ready? 250.66 for grounding electrode conductor sizing, right? Very important. 250.122 for sizing equipment grounding conductors, which go with branch circuits and feeders, okay, based on the size of the overcurrent device. Very important to remember that one. And then one of the tables that was derived from 250.66, but it stands on its own, is probably one of my favorite tables, being I serve on Copainter 5, is 250.102C. I think C1 actually, but that gets you where you need to be. That table is amazing because it determines the minimum sizing for the grounded conductors, supply side bonding jumpers, system bonding jumpers. It is an amazing table. And that's where we're going to go here because we're talking about what? A supply side bonding jumper. So you know this if you're in our course, but where would you go in the National Electrical Code? Well, you could probably go in here in your index and you can play around with it. And that's why I say dissect. So here I'm going to say, okay, well, let's see for something under supply side. just to see if there is anything under it. And that's what you should be doing, just kind of going through and seeing if there's anything in here that would be under supply side. And if you've already found other ways to do it, that's perfectly fine. But I'm going to look under here and see if there's anything under supply side. No. Okay. So we know it's bonding jumper. So we're going to look under bonding jumpers. And remember, this is why you want to start to do this slowly and look for these key terms, because the next time you see a similar question, okay, I might already know where to go. And I kind of told you table to go to. But this is why we dissect it. And you're going to get other questions like this or similar. Look, don't be in a hurry to answer all your questions. That's why I don't like the timers type of thing until you get down to the last 2 weeks. So let's see here. So let me go under bonding jumpers. Oh, kind of hit my screen there, folks. There we go. And let's see what we get under bonding jumpers. See what we got. I got to drop my glasses down, folks, because I'm getting old and can't see. Let's see what we've got here. Under bonding, okay, we have bonding. And we're going to go down. And let's see. I'm going to be looking for, let's see here. Look under, that's bonding. So now I'm not going to do that. I'm going to look a little more detailed than that. Let's see. Bonding jumpers. It says see jumpers bonding. All right, so we're going to go to jumpers. Okay. And again, if you're in our course, you guys already know where to go. You'd have been done with this question already. But we're now learning that if I have a question about bonding jumpers, that I don't go to bonding jumpers. I know that we go to jumpers, and it'll say bonding. Okay. This is why we do the index. And this is also why I wish Link with NFPA, if you're listening, add the index to it. It can't be that difficult to add that in. And it really helps us educators who use Link to teach. And we're always promoting NFPA's products, okay? Again, my screen keeps moving. Apologize. All right, let's see here. So let me go to, and it's doing it again. What is going on with my thing here? Okay, hold on. Let me just click away. All right, so let me go to jumpers real quick and see what we got. Okay. Move my glasses down. And when you're at jumpers, okay, I'm at J, jumpers. So I'm going to go down to jumpers. Not very big. You see bonding. And you come down. And boom, I see supply side. Okay. And I'm looking at that and I'm like, well, if you're very familiar with that, you know that that's not where you need to be under that. So I'm looking down. Let's see here. Equipment, no. Let's see here. Let's see. Okay, service equipment. The question was about service equipment. And it says, okay, since we're under bonding jumpers and it says service equipment, it's 250.28. That's going to talk about main bonding jumpers. We see 250.92b. It says bonding component. And we see 250.102c. That's where we know that we need to be. So again, that's just one way to find it. So I would have gone to services and I would have gone to knowing what I know. I would have gone to 250.102c and go from there. But again, here's the thing. Why I say take your time on these questions. Because you really need to look and see what possible way that you could find this answer. Okay. And the index is not going to be the holy grail, folks. I promise you. It's not going to help you pass an exam. If you've got to look up every question, that's not happening, okay? So I'm going to look under services, and you're going to learn, again, everything that you possibly could find it. Now, if there's folks out there that don't like this method, say that I'm taking too long, and if there's any pinhead out there that says, well, you only got 2 minutes, you've already taken longer than that, you don't understand how to study, you've been misled by your instructor, or you're just clueless, because there is a proven method. I have helped thousands of people learn the NEC. There's a method to the madness. You don't like my style? Do me a favor. Stop watching any of my videos. Unsubscribe. Remember, I'm not about the clicks. I'm here to make you a better electrician. Okay, so we're talking about how to dissect questions. And I'm beating this question to death. I'm getting my money's worth here. So I'm going to go to services real quick. And we're going to see if there's anything under services. Okay, so I've got my code book. I'm going to look under service. So here I am under services, or at least I'm under S. And I'm looking under service equipment. Okay, looking down to see if there's anything beneficial for me down here. And I don't see anything in there that's totally beneficial. They're going to help me anything. Now, under services, I'm just looking under the term service. And I don't see anything overly beneficial there. So while there might be other things in here, we have dissected this question down. And what we have determined that we would go to bonding jumper, right? And then it send us to jumper bonding. This is why I tell you folks, it's so important to learn tables and certain things in the code and do your best to commit to memory. Remember, 250.66, grounding electrode conductor sizing, okay? 250.122, equipment grounding conductor sizing. 250.102C, sizing minimum size for the grounded conductor, supply side bonding jumpers, main bonding jumpers, system bonding jumpers, all covered by that table. That's where we're going to go. So let's go to the code. And it's a 500 is what's being used, okay? All right, so we're over here, and let's go on and get me down to, let's get us to 500. 250, 102. So let's see here, bear with me as I work on my eyes here. All right, 250, now let's get down to 102. Much easier if you have a code book, probably. If you're dealing in being able to flip through the pages, you probably have a tab for it. Let's see, does my code book have a tab for that? Let's look and see. Let's look and see. Absolutely does. Of course, my tabs are beat to crap, but there is a tab that takes you right there. So that's another example why tabs are great, if you can do that in your state. All right, so let's look and see here. So here's 25102. As you can see right here, it's for the grounded conductor, it's for bonding conductors and jumpers. So that's bonding conductors and bonding jumpers. So here we go. Sizing, supply side bonding jumper. That's what our question was about. Now, if you notice down here, it says, and we only had one raceway, that's all it seemed to talk about. It says a service with a 500 kc mil conductor. Always assume copper unless stated otherwise. 400 amp service, and it's talking about sizing a supply side bonding jumper. That was our question. Well, here we go. It's size supply side bonding jumper for a single raceway or cable. It just says, shall not be smaller than in table 250.102C1, right there. All right, so here's the table. Let's click on it, expand it. This is what y'all are familiar with seeing. Over here, it's a 500 kc mil, so it falls between over 350 through 600. Again, that's 600 kc mil, okay? And then over here, if it's copper, then it's a 1-aught. If it was aluminum, it would be a 3-aught, okay? Now, remember, copper unless stated otherwise, right? So we're going to come back to our question, and it clearly is 1-aught. And here's your reference, 250.102C1 and the table that's associated with it. So why do we spend so much time on this? Because in an exam, you're probably going to answer this in 5 seconds. Okay, you're going to go there, boom, 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 done. The reason I dissected it is because we learned a couple things. You're not going to find supply side bonding jumper. You're going to find jumpers bonding. You go to service and give you multiple references. You should be able to look at that, and over time, you're going to know that 28's main bonding jumpers, okay? You're going to be looking at 66, and that's going to be grounding electrode conductors. You're going to know that when you see 102, that's going to be the minimum sizing for the grounded conductor, although it still has to handle the calculated load for the grounded conductor, but it can't be less than this table. You're going to do supply side bonding jumpers, system bonding jumpers, main bonding jumpers. All of them are going to send you here to this table. So you just want to get familiar with it. And that way it's going to save you a lot of time on exam. But by us dissecting it, we saw that the index is not the holy grail. There was a point, there was a method to this madness. I want you to not think of the index as a crutch, okay? The index is a helpful tool. But this is why in our Fast Tracks program, we teach you 19 units to minimize the need for the index, because we're going to teach you things that you'll just lock in your memory, and you'll be able to use to help you be more efficient on the exam. But I'm going to tell you something. I am a bit selfish. I am really not here to really be focused on you passing an exam. That's why you maybe got this course, but we sell other courses. My goal is for you to leave here and be a better electrician. That's what my goal is. Get Link on your phone, free. Okay, get Link on your phone, and well, not free. Link isn't free. My app is free, and we have a lot of resources on my app, calculators and everything like that. That's free. Pay for a subscription of Link once you get out in the field, and you'll be able to answer any question that you need. And if you're a student of mine, you know I'm always here to help you. Okay? All right, so anyway, pretty good question. Let's go on to the next one. Let's do another one. All right. Listed wall-mounted control devices shall be at the top and bottom of the stairways if there are blank or more steps between each floor. Okay, so this makes sense, right? You want to be able to turn the lights on at the top of the stairs. You want to be able to turn the lights off at the bottom of the stairs. You're getting ready to head up the stairs. You want to be able to turn the lights on. Again, this is a safety thing, but it's based on a number of risers that you have or steps. So where do you find this in the code? Well, so when you think about this, this is a lighting requirement, okay? And you're thinking, where do I find the rules for different branch circuits, different things that talks about the lighting, right? Well, we know receptacles and placements are 210.52. We can go back into the back of the book and see what we've got in the index, and you should pause this if you don't know the answer right away, okay? Because this one's got terms in it, and you could say, well, I'll look up listed wall-mounted control devices, a switch, if you will. And you say, well, there's very limited. Stairways. Maybe something's in the back for stairways, that type of thing. Or maybe you know that you're talking about the different devices, just like we would for receptacles in 210.52. Maybe you remember something like 210.70 talks about luminaires and things like that and the controls of luminaires. I don't know. Let's go to the book. So I'm going to go to the index. You get your index, pause this video, go to the index, and I'm going to look at a couple things. So first things, low-hanging fruit. I'm going to go and look up stairways just to see. It can't be that obvious, right? But let's just go look and see what we've got. And remember, you can always pause the video. And remember, you know, if you already know the answer, you mark it, you go on. You don't waste your time on it if you know it. If you got to use the index, this is where you're going to learn what is and what isn't in the index. Okay, so I'm going to go here and let's see. I've got stairway chair lifts. Okay, I've got nothing else other than that in the back when it comes to stairs. Okay, good to know, right? The next thing we'll look at here on this one is, let's say, luminaires, because obviously the wall switch here, or the listed wall-mounted control device, is doing what? Controlling a luminaire to make sure we have a certain number of lumens on the steps, so it's a safety thing, right? All right, so I'll go look under luminaries. And again, you're going to have some knowledge to be efficient in looking things up. So let's go look under luminaries and see what we see under luminaries, if there is anything under luminaries. Obviously, a defined term in the NEC now, so let's look under luminaries. All right, I got luminaries, and I'm going to look down and see what we might have under luminaries. Let's see here. And let's see here. Go down. Outlet requirements. Show windows, spray, strip lights. Okay. Not much help here under luminaries, unless I'm totally missing it. Now, I could be missing it. Except for the fact that we have to look down and go, okay, well, let's see here. Nothing else. Now, we do see lighting outlet requirements, right? It says see lighting outlets. Well, we know that this switch is going to be controlling a lighting outlet, so that might be something that would help us get to where we need to go. So let's go to lighting outlets, see if we can chase that rabbit hole. If you already know the answer, you mark it and you move on. If you know where to go, then you've been in the fast tracks because this is clearly covered in the fast tracks. So let's go to outlets real quick. And remember, outlets are not the devices you put in the outlet box. Outlets are a location which you put devices into. So we look at outlets and we kind of go down here and I go and we look at required outlets. Okay, so we know the required outlets are in, let's say, this stairway, and we know that the switching aspect of it is based on the number of steps. So we're going to go and look at, let's see here, we're going to go and look at, where were we at? We're going to go look at the outlets, and we're going to look at required. So we're going to go to part 3 of 210. Okay? So let's do that real quick. Okay. And let's see. So we're going to go to 210. Remember, deductive reasoning, index is not the perfect holy grail, but you got to look at the application. And if you're struggling, like, what are we talking about? We're talking about lighting outlets that are in a certain space that's required to be switched if we have a number of steps. And so where do we get the requirements for that? And other than go to 410, which is luminaires in general, we're talking about circuits right now. Everything we're talking about is circuits and switching and all of that type of thing. So let's go to 210. And I'm going to go to part 3. Bear with me here as I can't hardly see it. All right. Let me get to the beginning. Okay, so this is receptacle outlets, but you notice it says required outlets. Okay, we know what's required in the stairway. All right, so let's talk about it. So let's go down, bold scan. Everything's talking about receptacles. We can skip past that. We're not talking about receptacles and spacing. Quickly, you're moving through outdoor outlets. Okay, laundry, yada, yada, yada. We're moving through it. Guest room right there, 62, 63, meetings, not about it. Oh, boom. Lighting outlets, right? Indwelling applications. Now, remember our question. This is one of the important things about bold scanning. Let's go back just to the question real quick. And you notice it's talking about the number of steps. So you're looking for these numbers. These can be triggers when you're bold scanning. Also, the term steps. You could use the listed wall mounting. Kind of have all those jumbled around in your head as you're bold scanning. So we'll go back to bold scan real quick. All right. And you're looking down here. And what we're trying to do is right in here. So these additional locations. So these are your general lighting locations. But we're talking about in stairway, right? So we go down here and we're thinking, okay, where do we need to be? And, I see the word listed control device. Okay. I see stairway. Okay. I see between floor levels, stairway again. I see the term 6 or more. I see 6 corresponds with some of the choices we have. So that's where bold scanning, we're looking for things like stairway, all that type of stuff. And here's what it says. Where lighting outlets are required in an interior stairway with 6 or more risers between floor levels, there shall be a listed wall-mounted control device at each floor level and at each landing level that includes a stairway entry. All right, kind of clarification. So if you have multiple levels and you just have a stairway that goes from first floor to the second floor, and that's it, and even if you have a landing, if you can't leave that landing, then you only need the switching at the top and at the bottom. Makes sense? If you have 3 stories, and you're going up to a landing and there's an exit from that landing into the floor, then you have to have a switch at that landing because there's an exit onto that floor from that landing. So you'd have a switch at the bottom, at the top, and then on that landing. If it only was one level and you're going from the top to the bottom, is when it's 6 or more risers, you have to have a switch at the top and the bottom. If you have less than 6 risers, not required to have any of the switching on it. Okay, so there you go. How about that? Okay. Now, as far as the lighting, here's where the requirement here, additional, you have to have at least one lighting outlet controlled. Okay, so you got to have the lighting outlet control by a listed wall-mounted control device shall be installed in hallways, stairways, detached garages, detached. So that's the rule that requires the light there. All we did was look at the rule that requires when you have to switch it at multiple levels, okay, and the number of risers. So that takes us back to the question. Why did we spend time doing this? Again, I got my haters out there that say, you don't have enough time to do all that looking up. Then you're a pinhead and you don't understand why I teach people and why we're doing this. Please leave now. Don't waste my time. Those that want to learn know that we want to get our value out of our questions. You dissect it, okay? Remember, I didn't get in this industry to make friends. I came here to teach and make better electricians. Ultimately, at the end of the day, you're going to look back on it and thank me for my attitude and how I approach my teaching style, okay? Just is what it is. So answer this question, 6 or more. Again, your code reference, boom, right there. 210.70A23. Again, it took you a little bit to get there. The index wasn't as helpful, but you have to look at it and know what we're talking about here sometimes in a question and use some of your knowledge in the field. A lot of exams will have theory or code knowledge, and you're going to have to pull on your knowledge because in order to sit for your exam, you have to have a certain amount of time in the field. So it's assumed that you generally learn some basic knowledge. So in this case, you learned that this was talking about the lighting in a stairway, and it's talking about the switching of that required lighting and where you would put these switches or these listed wall-mounted control devices, where you would do that. The reason that this changed, folks, from switches to listed wall-mounted control devices, because there's other options today other than simple toggle switches. There's a lot of options out there. Technology has changed, so it was broader to call it a listed wall-mounted control device, and it might just mount straight to the wall. It doesn't necessarily now have to be powered from the building's electrical system anymore. We have a lot of wireless opportunities that are out there, so had to change the name to do that. But as long as it's listed and it is wall-mounted, you can control it. Here, it's needed 6 or more risers. Make sense? All right. This is just knowledge that you need to obtain, but we showed you how you could dissect it. And now you're learning what you can and you can't find from the index. All right, let's do one more, and I'll cut you folks loose. The next one we've got here is type MV cable shall be supported at a maximum of blank feet between supports. Okay, that's medium voltage. Where do we go for medium voltage? All right, you go to the index, and if you're going to use the index, that's pretty straightforward. Supporting question. So let's see what's under medium voltage. Do me a favor, pause this video, pause the video, and go under and look under medium voltage. Let's see here. I'm going to go here. All right, I'm in the back of the index, and I'm going to look and see if there's anything under medium voltage. All right, there's medium voltage, type MV, and it says supports, and it's sending me to 311.40. Okay, so we're going to see. So let's go on over to the code. All right. Now, one thing to remember here, this is the 2020 edition. It would be 311. But the 2023 edition of the NEC, so here's a little bonus for you. The 2023 edition created a new article for medium voltage. That's article 315. Code reference the same section, just a new article. See, that's why it's important to learn. This is a 2020. We're looking at 2023 examples. So let's go on and go over to it. Just kind of tricking you there, but I want you to be alert at what cycle you're using. So here we are. We would have looked in the back some sports. That would have been an easy one for us. We're going to go to 315 because we're in the 2023 edition here. As you can see, brand new. Kind of moved out of 311, put everything. And it also expanded because it used to be just medium voltage. Now it says medium voltage, conductors, cables, cable joints, and cable terminations. A little bit broader now for medium voltage. And we're going to go down to where it's said to go, down to 40. And I can click on the left and get me there a little quicker. And here we go. So here's our supporting, maximum between supports, okay? So here's, 40 right here. So what does it say? Type MV, oh, you got to see it here. Type MV cable termination of equipment installed in pull boxes and vaults shall be secured and supported by metallic or non-metallic supports suitable. Now you remember, our answers were numbers and feet. So we could skip the fluff, okay? Skip the fluff and get down here and be careful of how we read the question because it's asking about support. So here it says intervals not exceeding 5 feet from terminations or a maximum of 6 feet between supports. So what's the gut thing for you to do is, oh, you see that 5 feet and you go boom and hit it, okay? But then you're like, well, it was a maximum distance that it was asking. And it says maximum distance is 6 feet. So let's not make a mistake on an exam that you can't take back and go here and click 5. You want to click 6 because that is the maximum. And there's your code reference right there. All right. Folks, you know, learning the National Electrical Code, there's a reason I came up with this course. I get it. It's tough. And students that are in our program struggling right now, Unit 8, 11, and 13 is the toughest units in our program. I am here to help you. That's the difference in our program. You're not left alone. Now, we do have a budget program, which you don't get my additional support. But you can always post questions over at the Sparky Hub, and we'll answer your question. So you do get support. And it's a fraction of the cost of our full program. But I think if you go pricing around programs out there, really look at them, because I know people have told me, for $425 or $525 if you want videos as well over on our Fast Tracks tube. That's the difference between the black and the plus. Is the black is our basic course. The plus, you also get a year's access to all of our videos that we make over on Fast Tracks tube, which are exclusive. So that's the only difference in the two. We teach you the code. If you come into this thinking you know the code, we're going to tell you to forget what you think you know, start from Unit 1 and work your way through. That's what we want to do. And we want to teach you the NEC. I'm always here to ask questions. That's the difference between a structured program and just trying to answer questions on your own. We're going to teach you so that when you're in the exam or you're in the field, these things just come to you. All right? It's all about building up this memory, okay? This repository of knowledge that, believe it or not, it'll come out when it's needed, okay? All right. Hope you got something out of it today, folks. Till next time, stay safe. God bless. Hey everybody, Paul Abernathy here. Welcome to another episode here at Master the NEC and Electrical Code Academy, all sponsored by the Fast Track system where we teach you the National Electrical Code. So we have a lot of people that say, Paul, I don't like something in the code. I don't agree with it. Rather than saying that I just disagree. And I always say, well, if you don't like something in the code, you don't want to try to enforce it, which is a minimum safety standard, then you got to get the code changed. And people are lazy, right? They want to cry and moan about code rules. And instead of trying to comply, they find ways to circumvent them. They find ways to manipulate it and not follow these rules rather than just following the rules. Now, if there's something in the code that you disagree with passionately about and something that you can articulate why you disagree, and you have justification, substantiation, you have all that good stuff, then what you need to do is you need to submit a public input. So right now, public inputs are open for the 2026. It's going to be ending soon. I don't know when you get this video, but I want to show you how you do this. And maybe you missed the boat on the 2026 edition. That's okay. You can always do public comments to things in the process. You can be engaged, and I'm going to show you how you get engaged. But maybe the next time around for the 2029, when we finally get past the 2026, the gates will open and you can submit a public input to change the code in the 2029. So I'm going to show you kind of how this works. So let's kind of go to NFPA real quick. I want to show you how really easy this is. So here we are. All right, so I'm not signed in at all. In fact, you can't even see my sign in. So let me adjust this here while you're here. That way, people can see the actual sign in part. Okay, right there. Okay, just want you to see everything. All right, so here we are. Here's the sign in. You can sign in right here. You click sign in. And if you don't have an account, right, then you can come over here, create a profile. You can register and get an account. They're free. Doesn't cost you anything to get an account, okay? All right, so I have an account, so I'm going to log in. Remember, everybody can sign up for a free account. Just go to nfpa.org. Like I said, I'll go back and make it so simple for you. Here you are at the top. You go over here where it says sign in. You click on it. If you don't have an account right here, then you simply go over here and you create an account. All right. Now I have one, so I'm signing in. All right. So now I am signed in. You see there's my profile. Now, what do you do? Okay, I don't like something in the NEC. I think that I have justification to have something changed, all right? I can promise you right now, if you just submit something that you want changed because if it's a personal opinion, it's not going to make it, okay? Now, I'll also remind you that every person that serves on code panels, as well as everybody else, we have to submit public inputs the exact same way, okay? We don't just get together at the table and start doing this stuff. We have to submit public inputs just like anybody else. So first thing you're going to do is go up here to where it says codes and standards. Click on it. Now here it says a list of NFPA codes and standards. Click on it. Now you're going to come down to this list and you're going to come all the way down to NFPA 70, right? Sure, right here. See that's the National Electrical Code. I'm going to click on it. All right, now, see down here where it says next edition? Right there, click on it. And here is where you're going to see we're in the first draft stage. There's a first draft, there's a second draft, there's a NITMAM, all these different stages. By the way, this is where you would come to get all these nifty documents on the process, how the process goes, all that type of stuff, okay? All right, so right here, see it says submit a public input online, right? Here, submit, right here, submit a public input, right? Next edition, 2026, that's what we're working on. So I'm going to go in and click it right here. Now notice the closing date is September 7th. So if you're watching this after September 7th, don't think you can't get involved because once the public inputs go in, then they will become what's called a first draft. After we look at it, all the code panel members get together and look at it, and we'll put out a first draft. Then that's going to be released to the public. Then if there's something you disagree with the public with the first draft, you can get involved in the public comment stage. And you see that'll go all the way up to August 28th of 2024. So you can still be in the process, but if you want to get something new in there, you need to do it by September 7th. Now, if you miss the boat on this, don't worry. What happens is in a couple years, you'll be able to submit for the 2029. So it gives you a little more time to work on your public input to make it just right. But I want to show you the process because everybody acts like this is so freaking hard. Again, I have people that complain about this. They think they know what they're talking about. They say, I don't agree with the code. I think that's stupid. If you don't get and make change, then the old saying is put up or shut up. If you're not going to go make the change, then accept the way it is and move on. Do it the way the code is. Stop your griping. Make for change. Get involved in the process, right? It's not NFPA's fault. It's not code panel members' fault. It's your fault. You didn't get involved. All right, so I'm going to go down here. I'm going to show you what it's like to submit a public input. Now, what you'll get is this thing. You're hard to see it probably, but this is called TerraView. And this is what's so neat. It allows you to construct a code change directly inside of here. All right. So let's say I wanted to make a code change. Let's just say to 230.85, because I've been talking about that a lot today. So what you do is you navigate to 230.85, right? And you get down here, I'll click on it, and it'll come up on the screen. Now, all you do is if you want to change something, let's just goof around. Let's just say I wanted to call this emergency disconnects. Let's say I didn't like the name, and I think it should be emergency responders disconnects. I'm just saying. You can change anything you want here by simply clicking on it. So I'm going to click on this, right? And if I click on this, it adds to all of them. Okay, so it looks like I got to make change to everything in here. So let's see here. Now, if I want to add a new section, then I can't show you the screen. Let me move this up real quick. If I want to make an entirely new section, then right here, like maybe one that comes after 230.85, then I click this new section button right here. Right here. This new section button right here at the bottom right, right there. Okay. That maybe I want to make a 230.86 or whatever. That's where you do it. Now, if you want to edit the existing text like what I have here, right? Then you'll go down here. Now, you could not do this. You could change any one of these you wanted. Okay, you could click and change any one of these. Let me move this down a little bit so you can see everything again. You could change any one of these if you want. If I wanted to change this replacement requirement or whatever, but I want to do the title. So I'm just going to have to go through it all. And now I'm going to go down here to the bottom. Again, I'm going to show you here. I go down here and I'm going to click this button right here. You see it kind of blinking in the bottom right. I'm going to click that button. So let me click it. And it's going to load. And let me go on and drop this down while it's loading real quick. There we go. All right, now what you do up here is you can click anywhere in here. See how I'm clicking in there? And it's like a Word document. So if I'm clicking right here and I want to put emergency, and I'll put, let's see, emergency responders disconnects. All right, you see where I do that? I know it's hard to see. I try to zoom in a little bit. See where I just typed it in right here? It's basically a text editor. And maybe I want to say emergency responders disconnect, okay? Or just say emergency responder. See how you can edit it? So I can edit anything I want in here by just putting my mouse wherever I want. So if I was creating a new section, then it would be all fresh for me. But I'm editing one that's here. So I can do anything. I can do bold. I can do anything like that. So that's what I've got, all right? So now I've made my edits, right? So now I'm going to do what? I'm going to go down here, and what you see is after you make your edits, you scroll down here, you'll see that there's a button that says Next, right? Right here, it says Next. All you're going to do is click Next. So I've made my edit, clicking Next. Now, go back up here, you'll see what it did, and it also created a public input, and I'll zoom in so you can see this. It created a public input, so this one would be public input 25.20. So that's what goes on the record for that code panel, right? And here you see where it automatically marks out the disconnects and adds my emergency responder disconnects. That's a code change. And then you simply do what? You come down here and you go to the next. Or now, if you want to save it because you're not ready to submit it, then you can go down here. I'll show you. Don't worry. Right down here, you can click this button right here that'll save it. Okay, right here. It'll save it for you. You can come back later. Don't have to submit it now if you don't want to. And then, of course, you go and the next thing you do is you click the next. If you're happy with what you've done, you click the next. Now, what's next is it'll take you to this here. And this is where you can upload additional proposed changes, right? So if you have any graphics or maybe a document to support your information, any charts or tables or whatnot, then it'll allow you to add that to the file, right? Because it creates a packet that's going to go to the code making panel, right? So it's simple. You click upload file, you click on it, and it'll drop down here and it allows you to choose a file and upload whatever you want to support your change, right? All right. See how simple this is so far. All right, so I don't have anything, no images to add. So I just click next. And then it comes to this statement. Statement on problem or substantiation for public input. It is required. So you can't just say, because I think the NEC was having trouble typing today. NEC was wrong and I am right. That's not going to work. You need to substantiate it. Listen, all you folks out there who don't like certain things in the NEC, I'll use a great example. How many people out there think that 312.5c, where you bring all those non-metallic sheet cables through one connector in the back of an exterior enclosure, you think that's okay? Well, here you go. Here you go. All you got to do is go to 312.5c1 and change it, just like I just did for this one, and submit it. But you're going to have to justify. You can't say, well, this is how we do it in another state, or this is how we've always done it with no problem. I promise you, it's not going to pass that way. You're going to have to explain why it meets the intent of the code, why those cables are considered secured. And it's not going to work to say fire caulk. It's not going to work to say caulking. But if that's what you want to do, go for it. But this is what you have to do. You have to substantiate everything, right? Everything that you do has to be substantiated, okay? So when everybody says the code panel just gets things put in it because it wants it, that is not true. It must be substantiated, okay? Now I'm going to close this, and it's asking me, do I want to save it? No, I don't really want to save it. All right, so here is the one up here, and this is the one that I submitted. I'm just gonna, I think that's to delete it because I don't really think that change is necessary. So I'm just gonna delete the change. I didn't want it anyway. It wasn't submitted. As you see, it's not submitted, so I got rid of it. The point is, you follow through the process, and it's that easy to submit a public input. Anybody can do it. NFPA, they're free accounts. You go register for it, okay? And we love your comments, okay? But again, if you want to get it changed, you must justify it. So to summarize, you go to nfpa.org, okay? You click to sign in. If you don't have an account, you're going to register. Once you're registered, you log in. Then you're going to go, like I said, to the list of documents, okay? And then you're going to go down to NFPA 70. I'm not going to show you again. Go back and watch it again. At the beginning of this video, I showed you how to do that. Click on NFPA 70. Once you're in there, click Next Edition. When you get in the next edition, it will open. You will see where it says for the public input link. Click it. Now, if we get to the point where you miss the boat and you get the first draft, you read it, and now you can't introduce anything new now. You gotta comment on what's already been submitted during the public input and what was agreed upon at the first draft by the code panel members. If there's something you don't agree with, that's your opportunity to do the same thing we just did, but now you can go in and do what's called a public comment. So you're basically making a comment on the actions that the code panel took on public inputs. So you get to have a say everywhere along the way. So when people say this is not an equal process, it is. People say it's overrun by manufacturers. No, manufacturers are experts. That's why we need them on committees. But these are balanced committees. I know I'm gonna get some people in the comments that say, no, it's not, but chances are you're talking out your butt because you never served on a committee. You don't know what the work is like being on a committee. You've never experienced a committee. You just don't like what's in the code, and you think that it's been driven by manufacturers. Well, get off your butt. Start submitting some public inputs. Change the code. Be a warrior for code and change it if you feel that something's not right. But remember, you're going to have to justify it. Got to substantiate it, and you got to back it up. All right? Well, hopefully you learned something. Get out there, get those public inputs. We need it. Every 3 years, this code changes. We need bright people like you out there who can bring some insight to these codes. We'll sit at the code panel. We'll wade through it. We'll give it merit where it needs to be. We'll put it together and we'll put it out there for you to be able to give comments on it, and we'll make a better code. All right. Every 3 years, we strive to make a better code. All right. Till next time, folks, stay safe. God bless.